My name is Iván Ramos. I'm a senior researcher in CARTIF Technology Center. And in today's session, I would like to present the WILIAM Toolkit. This is the set of the tools that we developed based on WILIAM model. And this is a collaborative work that we developed in Work Package 11. And I include in the presentation all the authors of these tools that was part of this work package. The agenda for this session is based on a general introduction of the locomotion tools. After that, we will continue with the model and how you can run simulations. We will present the model analyzer and the functionalities, the model explorer and also the functionalities, and the last tool that is the gamification, which we call Crossroads to game. And to conclude, we will present the Python version of WILIAM. We can develop a simulation test on how to run the model in Python. And the final part is related with the documentation and the accessibility of the tools. Well, starting with the tools, at the end, all these modeling projects starts with the research question. This research question is based on the call. The call is the topic and the topic that we need to cover with our proposal. And basically, locomotion start with the development of a new integrated assessment model, and basically, as Inigo presented before, we have the IAM, and we have different scenarios as the baseline, green deal, degrowth, green growth, or post growth, or others. The combination of this IAM with the scenarios take the opportunity to provide some simulations, and these simulations are the outputs of our modeling exercise. And with these results, we have the opportunity to evaluate if we are covering all the aspects that are in the research question. The main end of an European project is to provide some deliverables with the results of all the exercises that you develop to create an IAM, to create the scenarios, and after that to evaluate what are the results and discuss, obtain conclusions, and so on. But in the meantime, we need to have this dissemination activities and to use the results for teaching, for create roundtables and discuss about the results of the modeling exercise, attend different workshops, try to explain what we developed in the past and how we can improve with the stakeholder needs and other aspects, and also to develop some scientific papers covering all the aspects that are behind our research approach. And finally, the project concludes with some policy recommendations that are the key part of a modeling and simulation exercise. The development of an integrated assessment model takes more or less the 50-60% of all the resources. But at the end, one of the key problems is that it's feasible to be used for other people that are out of the consortium or not. But if we use this amount of money to develop something that is not useful, we are wrong. But what are the problems? We need a huge learning curve. Always the documentation of models is not accurate or is difficult to understand. And one of the topics that we identify in the first stage of the project development is that not always the model is accessible. You usually need a proprietary software. the code is not open, and it requires a lot of computational cost. All these are problems and these issues generate that the model is forget and is not used. But these issues are a problem, but they are complemented with that to obtain policy recommendation, we need to create them based on a limited number of scenarios, and the opportunity to raise awareness on the challenge of the decarbonization will be waste because we don't have the opportunity to use the model and to run this policy recommendation with the modeling results. In this sense, we have the openness vision of locomotion, in which the model will be accessible for anyone who is interested in the challenge of the decarbonization. And why? We provide the WILIAM model that is ethically acceptable for all the modeling purposes. We have all the model open with that makes the model able to users in order to evaluate the hypotheses, assumptions, equations, and metadata. And we can contribute to the model development. All the users can contribute to the model development, documentation, and reporting bugs or other issues that you have during the evaluation of the scenarios. And what are the final goals of locomotion? Is to support the policy making, to contribute to the scientific progress, and to raise awareness and increase climate and modeling literacy. To this end, we will have the modeling toolkit that are the 3 modeling apps based on the WILIAM model that are tailored to the different users. We will have a tool that is targeted to experts and policymakers. Another one that is more user-friendly and easy to use that is allocated for the general public. And we also have a gamification tool that will help teaching in high schools and universities, providing an interface in order to evaluate what are the key issues of climate change and how you can create awareness in the climate issues. And also, WILIAM will be released in Python, and the metadata will be accessible by means of a data client that is now open in the locomotion webpage. And this data client includes all the information that are in the Excel files that Nico presented before. And you can share each specific variable, evaluate what are the meaning, the units, and how this variable is implemented in the model. All the tools are open source, and are licensed by MIT license. And the 3 different applications are usable in low power computers. You don't require a huge computational resource in order to run simulations with WILIAM. And also the model is well documented. We have an handbook that is now also available in the website in the deliverable section. Well, starting with the tools, in these tables you can identify the 3 apps, the model, and also the Python version of the model. And starting with the model is target for experts. The requirements are related with the benzene license. The model is stored in 2 different versions in order to be accessible via Diez license or only via reader of benzene. The simulation is in real time, and the computational cost, it is high, depends of the model is the computational cost is high, but the simulation, the time that you need to obtain the results varies depending on the model, if it is compiled or not. Only the questions are open source, and the model is licensed, as I said before, by using MIT license, and is available for Windows and Mac. Related with the Python version that is also tailored to expert. The requirement is that you need to have Python installed in your computer. The simulation is also in real time. The model requires high computational resource. Is open source. Is licensed using the same license as the previous version, and is supported in all the platforms. Well, these two versions are tailored to experts, and in this second one, you need to have some programming skills that, as we will see during this presentation, will be easy, but at the end, you need to be familiar with programming in some codes. This other tool is the model analyzer, that is a tool covering the experts and policymaker needs. The tool is based on WILIAM and will explore the impacts of the different policy options, but in a user-friendly interface. At the end, this is a tool that is very close to the WILIAM model in Python or in Benzene, and it's a desktop application that is running the model in real time. The tool is connected with a server, but you will have the opportunity to modify more or less the same parameters of the Excel file, but using a user-friendly interface. And the tool is available in Linux, Windows, and Mac. Well, the Model Explorer, that is the most easy to use tool, is tailored to the general public, for citizens in general, and anybody who is interested in the challenge of the decarbonization is able to use it because it's based on a really user-friendly interface. The tool is based on a set of pre-simulated results of WILIAM model, but it's also connected with a version of the model in Benzene in order to run real-time simulations. The computational cost is low. It depends on a server or from your internet IT connection, and it's supported for all the platforms using the same license as the previous one. And finally, the Crossroads game, that is an educational tool for the high school and university students. It's a web-based tool based on pre-simulated results of the model, and it requires a low computational cost. All the code from all the tools are open source, and the codes will be available at the end of the project in our website connected with a GitHub repository. Okay. Well, related with the WILIAM model, this is the main interface of the model when the model is open in Benzene. As I said before, is the target audience is experts, and we will have two different options. One is the binary file of Benzene. This is a version that is that could be opened using a Benzene reader. And the problem is that you need to modify the Excel file out of Benzene, and is not able to provide the changes in the equations. And the other version, that is the text file, is necessary to run with a paid license of Benzene, and you can modify or adapt the different equations that are behind the model. This is more development version, and you need to be an expert on the use of benzene in order to evaluate the equations and to provide some changes, because considering that all the models, the modules and variables are interconnected, each change in the model could affect in a negative way the results of the model. And this version is compatible with Windows and Mac users. This is the format of the download of the version of WILIAM. It will be ready during this week in the website. And after the download, you can see that the two versions of the model are stored in the folder. And you have these two folders covering the model parameters and the scenario parameters, in which the Excel files that were presented in the previous session are stored. Okay, this is the Excel file, and you can change and modify all the parameters in this document. And in order to run simulations, you only need to change the name here, and also click on this button to start running the simulation with the benzene model. It is necessary to consider that if you don't modify the number of variables that are collected in the outputs of the model, the size of the simulation could be huge. And this is a question that could be improved using external files in order to parameterize the outputs of the model. Well, continuing with each tool, I will provide you some explanations on how we can use the different tools. Well, the model analyzer, that is more from experts and policymakers, was developed by CREAF in collaboration with other partners from Work Package 11 and other external companies that help us with some developments. The tool is based on an architecture that is connecting a desktop app with a simulation server, and you need to install this desktop app in your computer in order to run the different simulations. It's compatible with Linux, Windows, and Mac, and this is the procedure to use the application. After installing the tool, you only need to create a new scenario, and well, after creating the scenario, you only need to define the initial simulation and the final simulation date, and create also identify the scenario with a name and a description in this part, and include also the reference scenario. We include here two options that are a completed scenario and a simplified scenario. This is related with a simplified approach that we include in the model. The simplified approach is related with the number of variables that you can use to run your scenario. And when all the parameters are completed, you can continue in order to run the simulations. When you click on continue, the desktop application connects with the server in order to run the simulation. And well, this is a summary with the general description and the general data that we include for the simulation. As you can see, these are all the parameters. We choose, for example, a full simulation with a final year. And we will have in the toolbar all the parameters, the modules, and the parameters that are behind the modules that are presented in this other screen. You have, for example, the demography module with a description of the fertility rates variable, and you can change and modify the parameters, in this case, using a drop-down menu. After selecting the value, in this case median, you can click finish to finish configuration to start the simulation. And this is the part when you have all the parameters modified. This is a summary of all the changes that you provide. You can evaluate before simulating, and after that simulate, you need to wait some minutes. And after this minutes of simulation, that it will be more or less 5 or 6 minutes, depending on the load of the server, you will have the results. And these results are plotted in your application, in your desktop application, under the plot menu. And you can select the different variables. You can change between the regions and plot the results. And well, the results can be downloaded as CSV files, and you can download the different images. This is more or less the idea of the model analyzer. This tool is quite similar to the Benzene version, but at the end, it's a user-friendly interface in order to simplify the use of the model. The next one is the Model Explorer tool. That is a tool more in the side of the civil society, and also it could be useful for policymakers. But it has only the simplified scenarios. The tool architecture is based on a web app, and it's covering two different approaches: pre-simulated results of the model and real-time simulation with a model version stored in a server. Well, as I said before, the application has a limited degrees of freedom in the variable management, covering also the policies and indicators. We work with a limited number, and this reason is that we identify what are the most critical policies in the models, and with this model we provide all the combinations between the variables in order to run these pre-simulated results. We include more flexibility with the connection with the server license, but at the end is only based on simplified scenarios. This is the figure of the architecture that is covering the part of the databases and the results that are pre-simulated with the model. And this is in the right part, is the connection with the Benzene license and the server. We also have the security issues covered by Keycloak as external manager for the user accounts. The tool is very close in the visual image as the previous one, and you have here a left menu with the opportunity to create a new scenario in which you need to include the name and the description. After saving the scenario, you can continue, and we have in this part a set of scenarios. Sorry. These scenarios are the baseline to start running your simulations. At the end, we will have here the business as usual, and 2 or 3 or 4 scenarios more related with the key issues in the decarbonization. And these scenarios will be the basis for the parameterization using different sliders or drop-downs menus, as you can see in the image. And well, when all the policies are parameterized here, you can visualize the results. As we are working with pre-simulated results, the tool is obtaining results in real time. But well, we will also have all the changes that you provide in the policies and the main outcomes that are collected from the model. And as in the previous one, we will have the opportunity to download the results and to download the image. And the last one is the Crossroads to game. This is a gamification tool whose target audience is teenagers, and the goal is to raise awareness in the challenge of climate change and how we can take political decisions in the current context of temperature increase. As the previous one, that is a web application, and is based on pre-simulated results of WILIAM model. The tool need to have two different roles in order to start working with them. One is the moderator, that typically is the teacher, and the other one is the players. The moderator is the person who is starting the game. The moderator will provide a code to divide people into different groups. And these groups that are covered by the different players are based on different roles. We have, for example, the social science, the energy expert, the economy expert, and the environmental expert. You can choose and change between these different roles. And yeah, we have two different game modes that are remote or in classroom. But at the end, you need to have consensus between the different options that you select in order to understand what are the concerns related with these decisions in the future. Okay, well, this is the part that I try to explain. Players need to choose between different predefined policy measures that are included as easy to understand questions. And at the end, we will have two different indicators that are the temperature increase and the economic growth. Players are split in teams and compete between the different teams. And all the policy options that are chosen by its team must to be discussed and agreed before the implementation in the simulation. For example, if we are working with this hypothesis one that is now on the screen, you have a chat in the right part in order to discuss with your colleagues in the team. You need to have an agreement, and if you don't have this agreement, you have a specific interface to discuss on the open questions in order to have a final decision. And after a predefined number of rounds, so these rounds are related with the time that you need to evaluate the differences between your selections and so on. You will have the result and finally the scores in order to identify what are the best group and and what are the decisions that they took in order to cover all the specific issues in the gamification. Okay, and well, before continuing with the the Python version, I will share another screen with the real version of sorry. Okay, this is the Model Explorer 2. You will have the different options. And for example, if you are you can register in the tool in order to store your different simulations, but you can continue without logging. In this case, all the information that you provide during the use of the tool will be lost if you are not registered. But if we can continue, as I said before, we have here a list of scenarios that are testing scenarios that you can use to create your scenarios. For example, these are all the scenarios are public, and you can choose one. For example, this one, that is, you will have here a preview with variables that are temperature and CO2 emissions per capita, and the main policy settings and outcomes that are implemented in these scenarios, and the other outcomes, and this indicator that is the temperature at global level in 2016. But if we can choose this scenario, you will have here the result and the policy parameterization in this other view. And well, you have the opportunity to compare two different variables, for example, renewable energies and unemployment rate, and the results of the simulation. But you can use this scenario in order to modify your variables. For example, if we can move to energy, we can modify the share of bioenergy, and we can improve the energy efficiency. And with all the changes that you provide, you can apply. And you can obtain this message that is related with the results are not stored in the tool, but you are able to calculate. This requires more or less 5-6 minutes. But if we can calculate, they give you a message that the scenario is running and calculating. Well, each time a user is providing a new scenario and running the simulation, this scenario is stored in the database, increasing the number of scenarios that are available for all the users. In this sense, we are covering the problem that we need time to simulate and store the results. And as I said during the presentation, this is the main indicator. Now we are running a new simulation, and the result will change when the simulation will finish. But we will have now these changes applied in the policy settings. These are the modifications that are related with the business as usual scenario, and not the modifications that we provide with this new simulation. This scenario is only a testing scenario that was created with the business as usual scenario in the tool. And these are the main outcomes that are listed with the indicators provided in the model. We include the Gini coefficient, the ROI, the CO2 concentration in the atmosphere, the sea level rise, or the ocean acidification. Well, this is more or less the idea of the Model Explorer tool. And also, you have here a new view covering all the model assumptions. These are the explanation of the variables that we include to run the simulations, but are not modified during the simulation during its simulation variation. This is an information provided in order to create transparency in the use of the model results. And well, continuing with the presentation, I don't have to see screen again. Okay. Okay. We will continue with the Python version of WILIAM. Well, to use this version, you only need to have a small knowledge on Python. We will cover all these aspects that are related with what are the main features of the Python version, what are how we can install an account in Python, that is a framework to use Python, how we can open an account prompt and move into the PyWilliam directory, create a new environment, running a simulation, creating and simulating new scenarios, and what additional configurations are included in the Python version, how you can plot the results, and finally, additional tools as exporting netcdf files to CSV. Well, WILIAM model is translated from Benzene to Python using the PySD library. This library was completely released during the project implementation in order to cover all the specificities of WILIAM model. As all the locomotion developments are fully open source with an MIT license and is multi-platform. In this image, that is the just paper in which our colleagues from CREA publish the PySD library and all the implementations that they need to integrate in order to cover all the specificities of WILIAM. Well, to run simulations using Python, the most easy way to proceed is to have this Anaconda package installed in your computer. You can go to this link and download the free version of this Anaconda distribution and choose the version and start the download. And well, after that, you can, after the installation in your computer, you can run the Anaconda prompt. That is this interface that is quite close to a CMD in Windows. But well, this is another view, installing the requirements from the simulation. And an important issue is that we need to create a virtual environment in Anaconda. What is necessary to create these virtual environments? A virtual environment is a way to create an specific installation with the package that you require and the version in order to have specific configurations for your specific project. For example, the current version of Python WILIAM in Python is running in the version 3.11, and you can create a virtual environment for this specific version of Python in order to run WILIAM simulations. To create these virtual environments, you only need to write in your Anaconda prompt this instruction that is the conda config in order to create the conda host channel. And after that, we need to create this virtual environment running create the name instruction, the WILIAM model, the Python version, and the file that is the requirement that is included in the download of the Python version. And after that, you need to have after creating this virtual environment, you need to activate only writing this instruction that is activate WILIAM. And also you can deactivate the environment running the deactivate command. Well, to run the simulation, you only need to have, as you can see in the screen, you only need to have activated the environment that is, as I said before, it is called WILIAM, and this is the folder in which we have our version saved. And we only need to include the command python run .py in order to run the simulation. As you can see here in the screen, the scenario file is collected from the Excel file scenario parameters. The initial time is set in 2005 and the final period is set in 2050. And the simulation step is now 0.25 years. The results are stored in the same folder that is specified here, but it creates a new folder that is results. And this is the time that the model requires for its simulation, the 35 minutes to complete all the simulations. And the results are stored in this netcdf file. Well, at the end, the final process, this is the time for simulation, but the results require time also. It spends more or less 39 minutes. Well, this is related with another command in order to modify what are the parameters that you can include based on a binary file. For example, if you need to create a new scenario that is visiting the green deal, you can modify the Excel files and provide this new Excel file based on this new command that is -x and the name of your scenario that it was modified in the Excel file. You can see here, this is the name that we include for this new scenario, but this change in the scenario implies that you need to modify the parameterization in the variables as it was explained in the previous lesson. And well, these are the additional configurations that you can include when you run the different simulations. -8 when you run the Python initialization, provide you the help, and this help present all the commands that you can include for the different simulations. For example, these model arguments that give you the opportunity to modify the final year of the simulation, modify the different time steps of the simulation, or save the output in the time in its time step of simulation. And the last part is related with the plotting. This is the same folders as I said before, in which we have saved the 5 William version. And we only need to run this plot command, that is Python plot tool.py, in order to plot the results. When you plot the results, you will have this interface. The interface that are in the back is in Linux, but this other one is for Windows users. And you can modify and change the variables. You can select and plot the results, but you have in the top part of the interface, you have a drop-down menu to select what are the dimensions of the variables. We will see this with a real simulation in the coming minutes. Well, these additional tools that are related with exporting the results from NetCDF to CSV, you need to have also the Anaconda Navigator that was installed with the general Anaconda distribution. And you need to launch and create a new environment in this navigator, and install all the libraries that are necessary necessary to open and run this environment. And using this Jupyter notebook that is part of the Anaconda distribution, you can create these algorithms in order to export the results. These are more advanced skills that requires at least more knowledge on Python development. But well, related with this part, but we'll continue with the slides that are related with the documentation and the tool accessibility. As I said in the first part of the presentation, we will have this data client that is a transparency tool in which all the information that are in the scenario parameters and the model parameters is stored. And you can provide some queries in order to evaluate what are the metadata that are behind the model. And we will have also this useful information that is the WILIAM handbook and the massive open online course that is object of this presentation. And to finish, this is the Locomotion website, and all the information is included in. This is the most easy way to plot the results. I made the simulation board in order to have results, but you only need to change the folder in which you are working. You can include you can change between C to D and activate the WILIAM environment. After that, you can only write a CD space and the directory in which your Python model is stored. And after that, you only need to run this plotting command. This command opens this new window in which you can load your data. You can go to the thing folder and load the data. And well, we can select, for example, a rooftop use of solar technologies. And these are the dimensions I said before. You can select, for example, European Union, and the results are plotted in this view. And you can configure different to plot, zoom in, or provide more information. And other variables, for example, other portions are only one dimension, and it's not necessary to change and evaluate between the different dimensions. Well, in relation with the website, all the information is included in this part of locomotion model. You have all the integrated assessment model, the database, that is the data client with all the information in the model, and the three different apps. In the next days, the model will be ready and included at the end of this page. We will include the specific form to download the model. And also we will include the Python version. The database is now running, and you can check it in this link, that is the data dictionary. And we include also a part of WILIAM result database that is storing the main results from the different scenarios of WILIAM. And the other tools that are the model analyzer, model explorer, and the gamification will be ready before the end of this month. This is all from my side. I don't know if you have questions.
Thanks a lot, Ivan. Okay, there will be a GitHub repository for the Python version, Ivan.
The main idea for today is that all the versions will be available from the website, but at the end we need to provide some repositories in order to store the code that we developed in the last months. But we are now working on the implementation, and it will be ready before the end of this month.
Okay, so Felix, they are not ready, but almost ready. So you have to wait the end of November.
Yeah.
Okay, so otherwise, thanks a lot, Ivan.